Right. Well, hello again, everyone. Tonight's CAD meeting. Before we start, I think one thing is that we didn't necessarily have everyone there at the in-person meeting last night. I know we got the schedule out a bit late, but still, those in-person meetings count towards your attendance percentage for lettering or staying on the team. So, keep up on that. If you really, really have something that conflicts that you absolutely can't be there, there might be a way that we can work around that and still have you do stuff that basically will count it as a meeting. Mainly what I'm thinking about is having people who miss meetings maybe fill out some like grant applications to get the team try to get the team some money. So, there's that. But the order of this evening is on shape, which you did miss that meeting yesterday. Yeah, we're kind of building off of stuff that we did here. Let me flip over to the PowerPoint. Of course, it doesn't really pick up on. Fine. All right. Well, so I am going to recommend that if you have multiple screens, use them. Like put the stream up on a side monitor, or if you have have a phone and a computer, put the Twitch stream on your phone on a stand, and then pull up, be ready to pull up Onshape stuff on your computer because this is going to be mostly a follow along with me lesson because we need to CAD something that will actually go on the robot. Also, thanks to everyone for saying okay to attend the meetings. So there's this address here. By virtue of being on a first robotics team, you all get a free Onshape license. So if you haven't already, you need to make an Onshape account. And if you, as you're making this account, please use your student email because I should have added all of you already to the 1806 Onshape team. Should see a screen like this when you're in Onshape. Never mind all this stuff down here. Mainly, like, might see that. Hopefully, see that. All right. Yeah. Okay. Everyone's ready. That was the end of the PowerPoint. So this is going to turn into an us just doing the thing stream. So you should see this FRC 1806 2021 folder if you're signed into Onshape. Click that. Got all these folders in here for like the shooter, the 2020 robot, prototyping, which is like our prototype stuff, testing sandbox. There's kind of documents in here. Um, okay, I'll deal with that later. But like you can actually like link things into it. Oh, you don't see the 1806 2021 folder at all? Okay, if you don't see this FRC 1806 2021 folder when you're in Onshape, you need to send me the email address that you created your Onshape account with. Just ping it to me in Slack or something. What I'm going to do is I'm going to do this create thing up here, and I'm going to create a folder while I wait for everyone to confirm that they can see in here. And I'm going to make a fall 2021 rollers folder. And inside here, I'm going to create what's known as a document. Now, ideally, everyone will hit that button inside this folder and name it Crowned Rollers, your name. Something like that. This one's, now the one I'm going to create is just going to be example. Then I will back up to see that other documents are getting created. Oh, let's see. Bill's, Crown Roller, Kevin. So yeah, all right. Well, that brings up a thing I actually didn't know about Onshape. You have to actually refresh it to see new files show up. Good to know. I would have thought it was like actively refreshing, but it isn't. So I guess I can do some explaining while waiting for everyone else to get in here. So, a document can hold a whole bunch of tabs down here for like different parts that are in the same document. Well as, assemblies. We actually won't touch on assemblies tonight. That'll be later. That's where you just throw multiple parts together. Graham did the thing, but he might have done it in the wrong place. Let me see. Yeah, well, okay, so Nathaniel has put it in the wrong spot. Let me see if I can. Oh, so if you made it in the wrong spot, like this. Yeah, a lot of CAD softwares are very similar. There's some idiosyncrasies of Onshape that I'll show you, but yeah, it's like Fusion 360, but and we'll get into it in a later lesson, but there's this thing called feature scripts, which is where you can actually programmatically make your own like features that you can add to things. Sure, no one's pinged anything at me in Slack. Okay, well, at least 3 people are ready and paying attention. Scream and yell in chat if you aren't ready. But, get into your document that you made, and it should look something like this in the Part Studio. I'm going to right click that and rename. Well, this works too. Properties works too. And name it flat roller. We're going to start with modeling the flat roller because that is a lot easier to do. And then, so unlike Fusion 360 or Inventor, like these are just kind of, these planes are just constantly displayed. Planes are kind of an important concept in CAD. You need a plane or a surface to start a sketch on. For this crowned roller, we'll, oh yeah, and then, okay. Let me get even more basic. So to rotate it like this, I'm right-clicking the mouse and dragging. That lets me kind of rotate it freely. And then there's this kind of little view box in the top. I can right-click that, do the same thing. There's these buttons here to change the orientation of it. So, you know, moving your view around is very important when using this because you need to be able to see what you're working on. So for right now, we're just going to use the top one. There's this little eyeball that pops up if you hover over like front and right. If you click it, they go away and you can ignore them for now. I'm going to hit the sketch button. It asks for a sketch plane. I'm going to click on the top plane. I'm actually going to rotate it around until top is showing. All right, and then if you need to slide your view, like pan over, middle mouse click and drag will let you just kind of slide over like that. So do not click this check mark. That will just complete the sketch. If you do that, you just have to like double click on it to reopen your sketch. And so what we're going to do with the flat roller right now is, so when you're in a sketch, the idea is to draw shapes and features that you're going to do modeling operations on later. For this roller, what we need to do is make a circle using the circle tool. And this is specifically a center point circle. That made a circle, but how big is the circle? Here, there's a dimension button, or you can even just hit the D key, which I actually am just learned right now is right here with you all. And if you click on that, that will allow you to define the diameter of this circle. Now, 4.955 is not what we need this to be. So I'm going to double click on this, get into the edit box, and the outer diameter of this roller needs to be 2.69 inches. Now, if you clicked on that and it came up with millimeters, what you need to do is you need to go down to should actually be a way to wait. Oh wait, did anyone have it come up and not inches? I'm going to take that as a no. So, does everyone like have a circle in a sketch that is 2.69 inches in diameter? Okay, to make it 2.69, what you do is you hit either this dimension thing, or you can even hit the D key on your keyboard to go into dimension mode and click on the outer edge of the circle, and it'll bring up a dimension thing and you type in the number. Now, if I do this now, it'll over dimension it because I already dimensioned it down here. But I'm actually going to get rid of that by clicking on it and hitting the delete key. All right. Now we're kind of looking at the roller from the top as we're making this sketch. That's kind of why I used the top plane. So the center of the roller is for hex shaft, 1/2 inch hex shaft to be precise. We're going to use this inscribed polygon tool, and on the center point, I'm going to drag this out. Now, it's actually assuming hex for us. Just click anywhere out here, and you can actually move left and right to define the number of sides that your polygon has. We want hex, which is 6 sides. And if you didn't get it that time, you can actually double that. You can hit escape to get out of polygon mode. Double click on this and you can change it to whatever. Hit 8, enter. We've got an octagon. 3, enter. Triangle. We want 6. And then similarly to so it's 1/2 inch hex, which is 1/2 inch diameter hex. Grab this and we do the dimension again. Click on the circle that the polygon is inscribed, and we want it to be 0.5 inches or 1/2 inch. Okay. So I guess we'll break out the forehead emotes again for when people have basically this on screen. Yes, that is hard using a touchpad mouse. I highly recommend, even if it's like a cheapo $10 mouse, getting a mouse for this. Actually, there's a I know because I ended up having my friend buy one of these when I was helping him build his computer. Is Micro Center has it's called like a Red Dragon brand mouse, and it's actually it's either $20 or $30, but it's really good for what it is because you can do all sorts of macros with it. Like if I have to recommend a cheap mouse, I'm recommending that one. I mean, there are cheaper mice, and if your budget can't afford a nice mouse, get the even cheaper mouse. But some mice are like $100, and I can't recommend them for this. Right. Yeah, a wireless Logitech mouse would be fine for this. My mouse is supremely overkill for this. It's like a glorious Model O or Model D minus. Yeah. Well, that's all 3 of you who had it earlier, so I guess we're going to continue. So now, click this green check mark, and now you're into kind of modeling mode. We're going to hit extrude, or you can do Shift E. I'm going to do Shift E because I need to get faster at this. So that brings up the extrude it window, and selected that face, and see how it kind of previews what you're going to extrude. If you've got experience with Fusion 360 or Inventor, this kind of concept is so we decided last night that the outer diameter of the roller needs to be 2.69, and we're using 3/4 of an inch wide belt. And so our roller is going to be 3/4 of an inch. And you can do this in any dimension you want. But instead of entering in decimals, you can actually do that. That gives us our 3/4 of an inch flat roller, 3/4 of an inch wide, 1/2 inch hex keyed. Roller. Now I'm going to come down here and see how after the extrude, it turned this into part 1. I'm also going to rename this flat roller, just for, keeping things straight. Now you can also go to assign material, on shape material library, and so this is actually going to be 3D printed out of PETG. And so it's got the density. So if you get this material assigned as PETG, you can actually go down here and go to display mass properties and then click on this part. This roller, if we print it in 100% infill, which we probably won't, will weigh about 0.2 of a pound. Just pretty heavy, actually, for a roller. So, that's why I'm probably going to go with something like 50% infill on this. Oh yeah, and it shows the center of mass, which is dead on in the center, luckily. It'd be really bad if we made something that's supposed to spin fast like a roller that wasn't balanced at all. So yeah, that's the mass properties. We use this a lot when we're so the material. So I went down to the part down here, right click, and there's this assign material dialog. And so it's in the on-shape material library, and I just started typing PETG because the filament that I'm going to use to print this is PETG. And it was already assigned, so I can just close out of that. You'll also notice next to the little scales in the bottom right, there's this measuring tape. That's also very useful because you can measure things like, did we get the diameter right? Yep, 2.69. Did we get the thickness right? Center distance 0.75, or bring it up. Measure. From there to there is 1/2 inch. Yeah, Onshape is a lot like Fusion 360, but there's some extra features that it has that I'll introduce you guys to later that are super mega ultra useful for FRC specifically. Pretty much this thing has like extra apps and feature scripts that you can add on to it to optimize your workflow, I guess. Like when we get into doing assemblies, there's an app you can get that just has like all the FRC parts suppliers parts like already modeled, where you can just be like, I need a sim motor, and you can just like pull it into your assembly. It's really nice. Speeds up a lot because in the past we would spend a lot of time just like looking up a CAD model of a part that we have on the robot just on random supplier websites. And now it'll just be in Onshape. Like you hit a button, type sim, add to assembly, go. Plus, we used to use Inventor, and that meant that like collaborating, it like kind of stunk. It's like I could actually, no need to follow along on this part. I could actually go into Kevin's document and be like, go look at his sketch and see that, yep, his sketch was done right. And if I want to be a real jerk, I could be like, go hit that update. And so if you watch that, and also before you guys all rush to do what I just did, don't go screwing up each other's rollers because we want to go like actually print these and use them on the robot. But if you're actually like collaborating and, you know, in the hypothetical universe where we're using a, you know, 3/4 inch hex shaft, you know, I could actually just go in here and fix their model for them. And then after I realized that I messed up in fixing their model, I could put it back to half. But also, yeah, that process of like double clicking on a sketch and like going in and editing dimensions, that's super useful because it applies back up, like, you know, the extrude just auto updates like it would in, just like it would in, you know, Fusion 360 or, you know, Inventor. Now I go back to the example. Yes, this is all cloud-based. It auto-saves. Like if your computer dies right now, it's saved. It also saves versions of it. So if I go back to, say I absolutely just like straight up oh, so what you can do is you can actually um, like, see this like versions and history window here. You can actually right click. I can actually go back and see like the start. See here. Oh yeah, and so like 8 changes. So I can actually go back to do that. So it saves like your entire list of undos. Like I could get back to main. I could completely delete everything and be like a real jerk here. I could actually create a version here. V1, description, finished, flat, roller, create. Now, main is still busted, but you can actually just well, you kind of just disregard it because hmm. Automod didn't want you to post the word jerk. Oh yeah, you can even like compare like versions. So like it just says, hey, main doesn't have anything. V1 actually has the roller. But yeah, there should be a way, and I don't know how, to basically just say like pretty much revert to that. Oh yeah, so if you know like Git and programming, you can actually do like branches. So like you can have like what I just did, create a B1 branch. You can actually be editing in, someone can be editing in main, someone can be editing in B1. Then you can should be some way to merge these. I don't know what it is, and I will figure it out before next meeting, but there is a way to merge these. But anyway, so yeah, we're done with the flat roller. Like, it's got a material, it's got everything. What I'm going to do is go back to the example. Right click. Anyway, I'm going to hit this little plus. I'm going to make a new part studio. I'm going to rename it Round Roller. So this one's going to be a little bit more involved to make. So we're going to start with the front plane here. We're going to kind of make this in a completely different way. I'm going to start here. I'm going to use the line tool and go straight up. See how the dotted lines appear when I'm locked to the straight up? That means you're, square 90 degrees up. I'm going to do that. I'm going to hit the D key to go into dimensioning mode. I'm going to make this a 0.75 roller. Go back to the line tool. Come out this way. I'm going to hit escape to get out of the line tool. Click again, click down here, and make another, square line out that way. I'm going to go back to dimensioning. This is going to be 2.69. This will also be, well, there's actually, yeah. I'll also make that 2.69. You can see how this is kind of a side profile. But what do you create new of? Oh, new part studio. So you end up with like another tab down here. Then I'm just gonna go down to the circle. Oh wait, so yeah, what we want is probably a 3-point arc. And then just put a 3-point arc down. I'm gonna put a line here and it's gonna lock. See how it like highlights that yellow? I'm gonna do that. I'm going to dimension the angle. I'm gonna make that like weird. Here, wait, so right? Because 270 would be square. Like 250 would be 20 degrees of crown. So we've actually fully constrained this. I'm kind of hacking this where instead of having to explicitly set a like radius for the arc, I can actually define my curve here just as like a departure angle. Oh, the lines? See this line tool up here? That's how you make lines. You can actually just hit the L key too. Oh, and Control Z is undo. Also going to dimension from going to make a line here. And I'm going to dimension okay. Huh, it won't actually tell me how much crown rays we have. That's a 25-degree departure angle because 270 is down there, so that's 20 degrees. Make it no. I don't want 35. I want 235. I think that's fairly exaggerated. Oh, I'm thinking 225. So forehead when you have something that looks like this. These lines I'm making here, you don't necessarily need to worry about. The reason I'm doing this is I just want to see it creates a point out here that I can use to reference. That's not what I'm gonna do. I can come down here to measure from that point to that line. So that's 155. That's that's a lot of. Oh, how far out does the arc go? It doesn't matter because what constrains that is this angle later. So it just needs to be like somewhere here. We're actually using the tangent and the line to tell how far that is. However, you could technically like do it this way too. The thing is with CAD is there's like usually about a million ways to do something. So at 0.155. Oh, actually just that down to 230. Go back to measure. Because as we were discussing last night, there's not, the amount of crown on the roller is kind of anyone's guess. Yeah, point. You know what? I'll go with 0.118 because that's a really good team number. They actually work out of the Johnson Space Center in Houston. Well, technically League City, but Houston area. Oh, the angle of the line that's sticking off. I hit dimension. So wait, do you have the line drawn already? If you have the line drawn already, and it's tangent, and it was tangent to that, all you do is dimension the line to this line up here, and then hold it out here, and it gives you an angle. Okay. I guess while we're waiting. Oh yeah, another one of the reasons that we went with Onshape is, build seasons, January, February, and we're in Missouri. We get weather quite a bit around then, to the point where we can't even get to the school. So as much as it would be nice to just be like, oh yeah, it's a snow day, everyone gets the day off. What would be ideal is that, if it's snowing, we just use, you know, things like Onshape and GitHub to be able to just continue working anyway. Because, first does not give us an extension for snow days. They don't push back our competition. So if we can use this and collaborate and get stuff ready to go, we can show up after a snow day with a bunch of designs ready to manufacture. That would be the dream. Oh, yeah, I can flip over to yours. So, um, one is yours. Sorry, I don't know you guys by your Twitch names yet. You just have a part studio. Oh, okay. Part studio 2. New. Oh, could you, yeah, work on that? Uh, oh, what you need, first thing I noticed is you didn't have these both dimensioned. That ended up being 2.69. Um, so we do to dimension that is this to this. And 235. Like, yeah. Yeah, so you can dimension like any kind of freeform angle. You can do something like that too. Like if I wanted to just be like throw an arbitrary angle here, you can just dimension here to here. And that is, exactly 56 degrees if you ever need to draw something at, a specific angle. Get rid of that. And mark. All right. I think everyone else who's following along has got it. Oh, yeah. Bill. I'll just check everyone's. You too. Oh yeah, you need to check off your I made a decent guess. 55, 2.69, 2.69. I mean, yeah, that looks good to me. All right, so once you got are to this point, what you want is oh yeah, see next to extrude, there's this revolve button. So what you want to do is you want to select your. I'm gonna have more sketch regions to highlight than you guys because I made these extra lines. And then for your, then you click on the revolve axis. And then you realize that we made a mistake when sketching this. But that's fine. We can show you all how to go and fix that. This is a radius that we were putting in, not a diameter. And I put in the diameter. And well, and then let me check something. Oh, and it's not 2.69, it's 2.534. Means I need to go back and edit the other one. Yeah, that. And it goes back and updates the rest. I'm just going to flip over back to the flat roller and fix that really quick. So yeah, so we've got the general shape of our crown roller. That's great. But now I need to go to the top, hit sketch, and then you can actually just select a like face on your object. We need our friend the inscribed polygon again. And then make sure you're centered on the top view. So you can use this point. Click out here again. Want 6 sides and dimension that 0.5. Now, when I try to revolve, the text turns red. Did you select an axis of like the revolve axis after you hit the face? That's down here. Is that what we actually want? Is like 0.512. The hex. It might have a little bit of play, but I don't want these to fit super tight on the shaft. I want to be able to like fit the hex shaft in it and not have to force it on, press fit. So I'm giving it like a couple 12 thou of built-in play. Right. So did you get it revolved? Inscribed shape. Go to sketch. There's this little inscribed polygon button. It's like the fifth one over. Yeah. It's this button. Roller and sketch. Coming out of the cylinder. Have you selected your here? When you're doing the revolve, it's coming out of the cylinder, not as round as that. You hit revolve. Oh, you need to select this face too. You need to select both faces, then hit that, and then the axis. And also you need to do the updates I did to your width there, but you can do that after you get the revolve done. Yeah, you have to select each one of these areas separately. The hexagon is 0.512. And that's, you know, I'm hoping that gives enough like clearance that we can just easily slide these onto our hex shaft. There you go. But yeah, also but also Nathaniel, you need to go back into this sketch and update your it's not 2.534, it's 2.534 over 2 because this ends up when you do build this the revolve way, this is your radius, not your diameter, and I accidentally had you guys enter in the diameter. This is my fault. Okay. Well, I think you have a slight problem here. So here's the new constraint. You can cut oh, the hexagon is 0.512 inches. 0.512. Um this So what I did there is this is the tangent. So when I was drawing this, I ended up with the tangent constraint when I just, drew the line. It kind of highlighted that and it just kind of auto did the tangent. But what's happening is you had kind of a flat spot on your roller where those kind of intersected and overlapped. And I just went in and tangented it so that it is the right way. back to this. So to cut the hole in this, what you do is you hit that. Oh yeah, and so there's these little tabs up here. We actually want to remove material to, this is like we, you know, took a piece of like PETG and put it on the lathe to make this rounded edge and made kind of a puck. And now we want to cut a hexagon hole through it. So we use the remove, select the hexagon, check mark, and there's your hex shaft hole. Oh, and Coach Zinovich came back with I'm going to go 507. Yeah, 0.507 on that. Because he seemed to want it to fit a little bit tighter than what I was defining it as. And then hit check mark. And it reapplies the extrude. So one thing to note is like the features are in order. So if you go and update sketch 1, like actually reapplies through everything below it. So then I guess while waiting, I'll just assign E 0.5212, but it looks too big. Do 0.507. Hold on. This is 0.193 pounds. But it looks too big. Hit check mark on your sketch so I can see it. I think your dimensioning is like the wrong thing. Let me delete that dimension. See here. No, that is not what I want. Dimension. The edge. No. Why are you doing that? Sometimes Onshape is a little bit silly. So when you hover over things, you can see like the constraints on something. Yeah, because it took your 0.512 and took it as a radius. So that is definitely too big. You have made a perfect hole for like inch and like an eighth hex shaft. Maybe not inch and an eighth, but the quick and dirty way would just to be to redimension it as 0.512 over 2. But I'm trying to find out. So what if I... No, I don't want to do that. Just saying that it's tangent to something. That was a constraint and I just got rid of it. really wants to dimension that as a radius, and I do not know why. What the? Let me try. And then that, yeah, it started working now. I don't know. Sometimes Onshape be like that. Manuals. Got it updated. He's ready to go. So the people that are around. Looks like everyone's got it. So you guys done all that. I think this concludes the lesson for now. I am gonna keep streaming because I'm gonna set up the 3D printer, but if you absolutely have to or want to go now, you can.